Hello, in this video we are going to learn about power reducing formulas and half angle formulas to help us simplify trigonometric expressions and solve trigonometric equations. So first, let's review some basic trigonometric identities. We know that sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent sine over cosine, and then we have our three reciprocal functions, cosecant, secant, and cotangent. We've learned our Pythagorean identities: sine squared plus cosine squared equals 1, tangent squared plus 1 equals secant squared, cotangent squared plus 1 equals cosecant squared, and we've learned our even and odd identities, where if we plug in a negative x for any of our trig functions, they all turn negative except for cosine and secant. Cosine and secant remain positive even when we plug in a negative x value. Be sure to have these written down on a note card or pause this video to take a picture of this slide if you have not already done so. We also have learned sum and difference formulas and double angle formulas. Once again, if you don't have those cards written down, then you also need to rewind the video, pause it, and take a picture of those. In this video, we're learning about power reducing formulas. So for sine squared x, we can reduce it from being a square to a regular plane function by using the formula 1 minus cosine of 2x over 2. We can do the same thing for cosine squared x by making it 1 plus cosine of 2x over 2. And tangent squared of x by being 1 minus cosine of 2x all over 1 plus cosine of 2x. Either write these on a note card or pause the video at this time to take a picture of this slide. We're also going to learn about half angle formulas and how to apply them in an equation. So we have three of these as well. Sine of x over 2 equals plus or minus the square root of 1 minus cosine x over 2. Cosine x over 2 equals plus or minus the square root of 1 plus cosine x all over 2. And tangent of x over 2 is either 1 minus cosine of x over sine x or sine x over 1 plus cosine x. There will be a strategy of whenever you use one of these, depending on which one fits better, but no matter what, they will both eventually lead you to the same answer. Once again, you need to write these down on a note card, or you need to pause the video to take a picture of this slide. An additional note is the plus or minus for sine of x over 2 and cosine of x over 2 will depend on where we're at in the unit circle. If we're in quadrant 4 on the unit circle and we're talking about cosine, of course it's going to be positive. But if we're in quadrant 4 and we're talking about sine, it would be negative. So make sure you reference your unit circle to know whether you are using the positive or the negative square root. Let's look at an example. We're going to use the half angle formulas to find the exact value of cosine 7 pi over 8. So here are our half angle formulas. The first thing we need to do is say 7 pi over 8 equals x over 2. So 7 pi over 8 equals x over 2. So we have 14 pi equals 8x, and dividing both sides by 8 and simplifying by 2, we get 7 pi over 4 equals x. So we know that this is equivalent to cosine of 7 pi over 8 over, I wrote that wrong, 7 pi over 4, 7 pi over 4 over 2. So now we're going to plug this into this equation right here. So let's see. Square root of 1 plus cosine of 7 pi over 4 all over 2. Now let's look at our unit circle to know if we need to use a positive square root or a negative square root. So I see 7 pi over 4 is down here in the quadrant 4. Cosine's my x value, it's positive, so I'm going to remain with the positive square root. 7 pi over 4 cosine is the square root of 2 over 2. So 1 plus the square root of 2 over 2 all over 2. That's going to be the same thing as saying the square root of 2 over 2 plus the square root of 2 over 2 all over 2. which is going to be, this is getting lengthy, just tall, 2 square root of 2 all over 2 divided by 2. And that is going to be the same thing as, we're going to write it up here, the 2 square root of 2 all over 2 times 1/2. So now we have 2 square root of 2 all over 4, which is the square root of 2 all over 2. And so that's where we're at right there. It's not very pretty, but it is the exact value. Okay, in this example, we're going to use the power reducing formulas to find, to rewrite, I should say rewrite, the expression cosine squared x sine squared x. So here are power reducing formulas. We need to use both the one for sine and for cosine. So let's rewrite this. We know that cosine is 1 plus cosine 2x all over 2. And sine is 1 minus cosine of 2x all over 2. And multiplying fractions, the top multiplies by the top, and the denominator multiplies by the denominator. So 1 times 1 is 1. 1 times negative cosine of 2x is negative cosine of 2x. Cosine of 2x times 1 is plus cosine of 2x. And then a positive cosine of 2x times a negative cosine of 2x is negative cosine squared 2x. And that's going to all be over 4. So we see that our cosine of 2x's subtract out to 0. So we're left with 1 minus cosine squared of 2x all over 4. Now what I see now is that once again I still have a squared, which means I need to apply the power reducing formulas again to get rid of that squared. So to do that, I'm going to use the cosine squared x formula, which is 1 minus, let's put it here, we're going to put parentheses around it, 1 plus cosine of 2x, we see our x is 2x, all over 2, all over 4. So now we have 1 minus 1 plus cosine of 4x all over 2 divided by 4. So let's rewrite this right here as 2 over 2. So 2 minus 1 is 1 plus cosine of 4x all over 2 times, this is 4 over 1, right? 1 over 4. So now we have 1 plus cosine of 4x all over 8. So cosine squared x sine squared x equals 1 plus cosine of 4x all over 8. Once again, here this was a 1. Right here, this is a 1. We changed it to 2 over 2, so we have common denominators. 2 minus 1 is 1. And then we took this denominator here and we flipped it so that we could so we wouldn't have a fraction inside of a fraction anymore. So this is our final answer here. Okay, so that's using power reducing formulas. Let's do another, Okay, in this example, we're going to find the exact solutions in the interval from 0 to 2 pi. So this time we actually have an equation. 0 to 2 pi tells me that I'm going to reference the unit circle, and then I see the equation sine of x over 2. The x over 2 lets me know that I'm going to use the half angle formulas. So here, I'm going to need to plug in the 1 minus cosine x over 2. So I don't know if it's going to be plus or minus, but we're going to take care of it in just a minute. 1 minus cosine x all over 2 minus cosine of x. Now, what we see here is a radical. We see a radical, so we learned back in Algebra 2 trig that we need to get rid of the radical, we need to square it. So we're going to square both sides. After we set it equal to 0, I'm getting ahead of myself. So plus or minus the square root of 1 minus cosine of x all over 2 equals cosine of x. So now we need to square it. So we learned how to solve equations with radicals in the past. 1 minus cosine of x divided by 2 equals cosine of squared x. Now to get rid of the divide by 2, we're going to multiply both sides by 2. So now we have 1 minus cosine of x equals 2 cosine squared of x. Now what I notice is that I have a squared. This is letting me know that it's a quadratic. So I need to rewrite this, and I need to set it equal to 0. So I can say 0 equals 2 cosine squared x plus cosine of x minus 1. I could also write my 0 on the other side if I needed to. I could rewrite this. I could use substitution. I could say, let's pick any letter. Let's just say y. I don't like y. Let's say t equals cosine of x. So now what I see is 2t squared plus t minus 1. Now this looks like a more familiar quadratic. I know that 2 times 1 is 2, and 2 minus 1 equals 1, and I put both of these over 2. So this is 1 over t, put both of them over 2t. So I have 1 over t, negative 1 over 2t. Bottoms up, I have t plus 1, 2t minus 1. That all equals 0. But t is cosine. So I have cosine of x plus 1 equals 0, and 2 cosine of x minus 1 equals 0. So cosine of x equals negative 1, and cosine of x equals 1/2. Remember, though, that this problem told me about this interval 0 to 2 pi, which told me that I needed to use the unit circle, right? So guess what I already have showing up on this slide? A unit circle that I kind of wrote on top of. Oh well, it's okay. So we're looking for where cosine is negative 1. Cosine is our x value. So the only place cosine is negative 1 is at 180 degrees, or pi. So we know that x is going to equal pi. There's our first answer. We don't see negative 1 as a cosine value anywhere else. But we also need to find where cosine equals 1/2, which is at pi over 3 and at 5 pi over 3. So now we know that we have, let's write in the same color, pi over 3 and 5 pi over 3 as our answers. So the solutions to this equation are pi over 3, and 5 pi over 3. So I'm pretty sure that's our last example. If it's not, then we'll keep going on. But if it is, then this concludes